This example, or these two examples, we're going to be talking about whether mean value theorem applies or Rolle's theorem applies, and we're going to kind of answer some questions along with that. So first thing, quick refresher is Rolle's theorem. If you remember, you're talking about 2 points. They're at the same y value. And so if this graph is continuous, it's a guarantee that we have a slope of 0 between those two. And then the mean value theorem is if you have 2 points that are not at the same height, but the graph is continuous, whatever the graph looks like, that somewhere between those 2 points, you're going to have a slope that's going to be equivalent to the slope between those 2 points. All right, so that's kind of the basic idea. This one is slope of 0. This is a specific slope that is going to be equivalent to whatever the slope is between the 2 points. So we got to go through all the little steps. So the very first thing is that we have this function, 1 over x squared on the interval from -3 to 3. So let's start going through the pieces. So does f of -3 equal f of 3? Don't know. So if we plug in -3, we're looking to plug it into this. So it's 1 over -3 squared, which is a ninth. If we plug in +3, we get the same 1 over 3 squared, which is a ninth. So potential Rolle's theorem. However, it needs to be continuous because if it's not continuous, I have no idea what's going on between these points. So since this, your x, cannot equal 0 and 0's in that interval, we have a bit of a problem. So no, x cannot equal 0. So it's not continuous. We actually have, sorry, let me answer this. So yes, so potential Rolle's, you have a vertical asymptote actually right there. So doesn't matter if it's differentiable, but it is not. No, because we have a domain issue right away. So it's not going to be differentiable at that point. And then neither Rolle's theorem nor mean value theorem are going to apply. So that one's a no. And then doesn't matter. We can't use either of them. So this is not applicable on that. All right, so let's shift to the same equation, different part of the same equation. So now we're talking about the interval from 3 to 6, which is continuous, but let's take a look at your points. So if you plug in 3, you're getting 1 over 3 squared, which is a ninth. If you plug in 6, you're getting 1 over 6 squared, which is 1 over 36. All right, so we have different y values, so it's not Rolle's theorem. Is it continuous? Yes. So do they equal each other? No. If it is it differentiable? Yes. There's no breaks, no weird spots in between. So we're looking at mean value theorem. So what that means is we need to find the slope between these 2 points, between 3 and 6. And we need to plug it in. We need to find the slope, do our derivative, and figure out where on that graph from 3 to 6 has that exact same slope. So first thing is let's find the slope. So we have 3. When we plugged in 3, we got a ninth. When we plug in 6, we got 1 over 36. And so we need to find the slope of that. So if we do the slope, we're doing y2 minus y1. So 1 over 36 minus 1 over 9 divided by 6 minus 3. So we have 1 over 36 minus 4 over 36 with a common denominator divided by 3. That's going to get a -3 over 36. And instead of dividing by 3, I'll multiply by the reciprocal. 3's cancel. We're looking at a -1 over 36. Okay, so there's our slope. So next part of this is let's do our derivative. And our equation was 1 over x squared. But let's avoid quotient rule by bringing the x squared up. All right, do our derivative. So that's going to be a negative 2x to the negative 3. So let's adjust that back to a fraction. Negative 2 over x cubed. Right? And so we're saying that on this graph, from 3 to 6, somewhere there's a slope of negative 1 over 36. So we're going to take our slope equation, negative 2 over x cubed, and we're going to set it equal to this specific slope and try and solve it. All right, so we'll cross multiply. If we cross multiply, we're going to get x cubed equals 72. Negatives are going to cancel each other away. So 72. So then from here, we would cube root both sides. Cube root both sides. And it depends on if you're looking for an exact or an approximation. If you're looking for an exact, I can take an 8. I can factor an 8 off of that, and 8's a perfect cube. So that'll become 2. So our exact answer is 2 cube root 9, which is approximately, and I do this for a reason, approximately 4.16, right? On. So the reason I do that is I do want the exact or a decimal version of it because I need to make sure that that value sits in the interval. Because that value should, but you might get multiple answers because based on the original, whatever problem you're getting here that you're solving, you might get multiple answers and not all of those values are going to fit in that interval. So you got to kick them out. So we have that one. It's in the interval. It's supposed to have been in the interval. So that's great. So in the interval of 3 to 6. So our answer is the instantaneous rate. Instantaneous rate of change at x equals 2 cube root 9 is negative 1 over 36. So that's the slope at that point. All right, and that was kind of walking through a couple different examples of whether Rolle's theorem applies or mean value theorem applies, when it does, when it doesn't, and if they do, how do we finish the problem?